When we solve a system using substitution, what does that mean?
So like for the first one, we would like do equal to divided by x and then put y on the second one.
So we have to solve for a variable, right? We have to solve for a variable in one equation and we have to substitute it into the other equation. Now these instructions say solve one equation for y. Does it have to be y? It doesn't. Okay, it doesn't. Now I know the instructions say solve for y, and I will tell you probably on this paper, on these 6 problems, you're probably going to want to solve for y, but I want to talk real quick about how you know which one to solve for. We talked about this back when we did linear equations, but I want to talk real quick about it with nonlinear systems. Okay? So if we're looking at problem number 1, which of these variables do you think would be the smartest to solve for? So, am I allowed to solve for any variable? Yes. Okay. Are there smarter variables to choose? Yes. Okay. There are smarter variables to choose. This variable doesn't have a coefficient. This variable doesn't have a coefficient. This one does, and this one doesn't. So if I'm having to choose here, I would not choose that one. Now, the coefficient isn't very big, so if that was an issue, it would probably be fine to solve for. But another thing to think about is if I'm solving for this x right here, I'm dividing everything by 2, which is going to give me a fraction, right? A fraction here and a fraction here. And I know that you guys well enough to know that if you don't have to deal with fractions, you don't want to, right? We could even go to the decimals, but still that's a decimal that we would have to deal with when we wouldn't have to if I chose something else, okay? Now here, these are very small. There's no coefficients, but how do I get one away from the other? I'd have to divide. And if I divide both sides by something, I'm going to get a fraction, right? So maybe I want to try to stay away from these if I can't help it, right? So that leaves what's left to be this y. If I subtract 2x from both sides, have I now solved for this y? Yes. And it's just 11 minus 2x. That's relatively simple to plug in to solve for. Does that make sense? Look at number 4. Okay? Because so far today, number 4 has seemed like the ugliest problem. Would you agree with that? That number 4 seems like the ugliest problem? They're long, right?
Yeah.
Okay. So if you were having to decide which variable to solve for on number 4, which one would you choose?
Probably the one.
So first of all, probably a y, right? Whether it's this y or this y, it's probably a y, because can you solve for the x in this problem? No, there's an x squared and an x. I'd have to get those isolated by themselves to be 1x before I could solve for it, and I can't do that. So that takes out the x in this problem as well, right? Because it has an x and an x squared. Okay? So am I going to solve for a negative 2 or a positive 3? Am I going to get rid of a negative 2 or a positive 3? So there's arguments either way, right? Some people don't want to have to deal with a negative, and they don't want to solve for this y because they'd have to divide by negatives, and they know the negatives sometimes mess them up, right? But if I go over here, it's a positive, and that's great, but that means I have to divide everything by 3. If I divide this by 3, what's that going to give me? Fraction. If I divide this one by 3, that's going to be fine. That one's going to be fine. So it's going to give me one fraction to deal with, right? But if I divide this one by negative 2, do I have any fractions? No. So that's going to kind of be up to you. Do you want to deal with one fraction over here, or do you want to make sure that you get all your negatives in the right place over here? It's a personal preference, isn't it?
Yeah.
Okay? So deciding which one of the variables to solve for is sometimes kind of a difficult first step. But once you do that, you know what to do, don't you? You solve for a variable, you substitute it into the other equation, use that to solve for the variable that you need. When you find that variable, you plug it back into the other equation where you've already solved for a first variable. Does that make sense? Do you have any questions about this? Okay. Notice, please, that there's more functions here than there was even on the worksheet yesterday. Do you remember what shape this is? When they're both squared? It's a circle. So this is not even a function anymore, is it? Okay. This one right here, if you divide both sides by like 4x or something, if you're solving for y, that's going to give you a rational function, right? Some of these are parabolas. Here's another. This is not a circle. This is an ellipse, like a long elongated circle, because the coefficients are different. So that's an ellipse. So we've got different things going on here, some of them which aren't even functions. But what are we looking for?
Y.
We're solving for y so that we can find the points of intersection, right? That's where our solutions are, is the points of intersection. And whether or not it's a function, you can still find points of intersection if there are any, can't you?
Yes.
Okay, do you have any questions about this? You good?